Hello and a warm welcome to the Sleepy Physicist. I'm so pleased you're here. This is a place to rest, to contemplate, and to softly drift away, whether you're settled comfortably in a cozy bed with a blanket or just letting your thoughts begin to unwind. Tonight, we'll embark on a gradual, quiet exploration into one of the cosmos's most mysterious and powerful concepts, the black hole. I'm referring not to the terrifying, galaxy-devouring monsters from science fiction, but the real kind, a cosmic location where gravity becomes so intense that not even light can escape. We'll begin not with a bang or a spectacle, but with quiet, with shadow, and with the slow pull of something you can't see, yet which somehow feels aware of you. And just a quick note before we start. If this space brings you a sense of peace or helps you relax a little more easily, it would mean a great deal if you would gently tap a like or subscribe if you haven't already. Super thanks and channel memberships are also wonderful ways to support the channel if you feel inclined to. Your support helps me continue creating this tranquil little corner of the universe. If you're feeling comfortable, please share in the comments where you're listening from and what time it is for you. I find it beautiful to see this gentle network of drowsy minds light up all over the world. And now, let's slowly and tenderly move inward, drawn by the call of the unknown. You are floating, not exactly dropping, not tumbling or hurrying, but softly gliding through something vast and silent. Here, there is no wind, no stars flicker. There is only a deep, velvety darkness that appears to stretch on forever. And now you are a part of it. You don't fight it. Something in front of you beckons, not with sound, but with its presence. It doesn't yell, it doesn't glow, but it pulls. This is the kind of pull you don't question, like a tide that knows your name, like sleep. When your body has become heavy and the night feels long, you surrender to it. Not because you're forced to, but because it feels natural. This pull is gravity, but not the familiar kind, not the gentle force that holds you to the earth or keeps the moon in orbit. This is a gravity that has lost its politeness, a gravity that no longer whispers gently, but leans in close, wrapping space and time around itself like a tightly pulled blanket. You're approaching a black hole, but before you picture swirling whirlpools and monstrous devourers, pause, because that's not what you'll find here. There is no swirling, no glowing. In fact, you don't see anything at all. And that is the first major secret of black holes: they don't reveal themselves. They are not objects but voids, not shining stars but gaps in the sky where something once was. Perhaps long ago, a star existed here, immense, radiant, and powerful. For millions of years it burned brightly, fusing atoms into light, fending off gravity with its immense heat. But even the brightest stars eventually deplete their fuel. When that happens, their own mass turns against them. The collapse is sudden and violent. The core implodes, and in that crushing moment something incredible occurs. It becomes unimaginably dense, so dense that not even light can break free. And just like that, the star vanishes from sight, leaving behind only its influence and its pull. You can't see a black hole, but you can sense it. You are not alone in your curiosity. Throughout the universe, dust and stars, planets and light all react to this unseen tug. It warps the paths of galaxies. It bends the journey of starlight. And yet it remains still. It simply waits, silent, unwavering, patient. You start to notice something else. As you drift closer, space itself seems to stretch, not in terms of distance, but as a feeling. Here, time slows. Seconds drip like honey. Your thoughts move softly, deliberately, as if caught in a gentle current of cosmic molasses. The farther in you go, the slower everything becomes. This, too, is a fundamental part of a black hole's nature. It doesn't just trap light, it warps time. If someone were observing you from a great distance, they would see you slow down, pause, and freeze, as if you were forever stuck at the edge. But to you from within, everything feels normal and calm. That edge even has a name: the event horizon. It's not a wall or a physical barrier you can touch, but a point of no return. Once you cross it, no information, no light, no message can escape back into the universe. It is not an ending. It is a separation. A severing of connections. Yet to you, it feels like floating into a dream. You don't fear this place. You're not falling uncontrollably. You're gently gliding toward understanding, toward one of nature's deepest enigmas. For centuries, thinkers have grappled with the concept of black holes. Newton viewed gravity as a force between objects. Einstein redefined it as the curvature of space itself. Now, with black holes, we encounter gravity at its most extreme, a place where our best ideas begin to fall apart. And yet, even here there is peace. You notice its absolute silence. Not just a lack of noise, but a profound silence. There's no sound in space, of course, but this silence is deeper. It feels like the pause before a thought, like the moment between questions. And still, the pull continues. You wonder not with fear, but with curiosity, what lies past the horizon? What awaits beyond that point where no story has ever been told? Is there a center, a singularity, a place where time ends and density becomes infinite? Or is that just a way for math to tell us, I don't know what happens here? You rest in the thought, not needing an answer, because black holes aren't here to provide all the explanations. They are here to remind you that mystery is a fundamental part of the map, and that not knowing can also be peaceful. Behind you, the universe still stretches out. Stars and galaxies swirl, comets arc in cold loops. Ahead, the horizon waits, gentle and absolute. You exhale slowly. The pull is not over, it is deepening. And just ahead, something stirs. Not a star, not a planet. It's another black hole, moving toward you not in pursuit but in a cosmic dance. When two black holes meet, the very fabric of reality begins to ripple. There's a moment, as soft as a breath, as weightless as a pause, when light starts to hesitate. You are still drifting softly, but the space around you has changed. It no longer feels limitless. It bends, curves, and tightens, as if reality itself is pulling inward, folding into a secret. You follow the path of a single photon, a tiny sliver of starlight, as it dances toward a place from which it will never return. It starts as confident, straightforward movement. Light always travels forward. But here, near the black hole's edge, that certainty begins to break down. The photon slows not in speed, because light always travels at its maximum speed, but in its progress. Its path twists into a spiral, a shrinking circle that tightens with each loop. It is now trapped, not by a physical wall but by the very shape of space. This is the edge, the event horizon. It is not a barrier or a surface, but a boundary defined only by what it prohibits. It doesn't push you away or pull you in. It simply marks the point where escape becomes impossible. From this point on, any beam of light, any whisper of matter, is lost to the external world forever. Not destroyed or erased, just unseen. Yet the event horizon isn't harsh. There is no jolt, no violence. If you were to cross it, you wouldn't feel a bump or a sudden change. Everything would feel strangely normal until you realized that the sky behind you no longer mattered, and that no signal, no message, no part of you could ever return. You hover just outside it now, not in danger, but in awe. Around you, light performs a strange ballet. Some rays of light circle the black hole endlessly, like moths caught in a glass jar. This delicate point of balance is called the photon sphere, a thin band where light can orbit in perfect rings. It's a haunting image. Light, which was meant to travel in a straight line, is now caught in a curve it can never escape. But most light is not so lucky. The paths bend too far. Some beams skim the edge and spiral inward. Others, launched from within, try in vain to break free, only to be swallowed quietly by the gravity they cannot outrun. You think of escape not as a door but as a possibility. And here, that possibility has been eliminated. It's strange, isn't it? That light, the fastest thing in the universe, can be slowed not in its velocity but in its freedom. It is still moving at its regular speed, but the space beneath it is shifting, tilting inward like a massive cosmic whirlpool. The black hole doesn't grab light with hands. It holds it by curving its path so thoroughly and completely that what was once forward becomes inward, and what was outward becomes just a dream. And in that realization, you begin to grasp something more profound. Gravity isn't a force in the traditional sense. It is the very shape of space and time, and a black hole is where that shape folds in on itself like a secret collapsing in the dark. You imagine space as a soft fabric, perhaps velvet or fog. Typically, it is smooth and mostly flat. But here, near the event horizon, it plummets downward like a well with no bottom. Not just space, but time as well. The direction of time, which you typically perceive as forward, begins to tilt toward the center. This is why nothing can escape, because to escape would require moving backward in time, and that simply doesn't happen. You sit with that idea for a while, not pushing it away, not needing to fully comprehend it, but simply feeling its shape and letting the wonder of it settle into your breathing. You also wonder what it means for light to disappear, not just to go behind a curtain, but to cross into a place where it no longer matters. From the outside, a black hole is defined only by what can be measured: its mass, its spin, its charge. No information about what fell in remains. This is called the no-hair theorem, the idea that black holes have no memory of their specific details, only their weight. But is that truly the case? Is the information gone, or is it just hidden? That question still echoes among physicists today, reverberating like light orbiting the photon sphere. Hawking believed it was lost. Others think it is somehow stored, encoded on the event horizon itself, like a cosmic ledger holding secrets we cannot yet read. You lean in as if your breath could stir the fabric, as if your thoughts could catch the lost signal of light. Because somewhere deep within the darkness are the echoes of everything that has ever fallen into stars, dust, time, memory, all held behind the soft veil of the event horizon. And yet, strangely, nothing here feels menacing. There is no scream, no rupture, just the stillness of a place where motion forgets itself, where light is not dimmed but curved, where time doesn't end, it just slows until it forgets how to move forward. And as you watch, you see a shimmer, not light but a change. The space around the black hole begins to tremble, not violently, just gently, like ripples on a pond stirred by something unseen. Something else is approaching, something massive, another black hole. And when their horizons start to merge, space itself will begin to resonate. There is something oddly serene about it. The black hole in front of you doesn't demand attention. It does not gleam rage or swirl with fire. It has no surface, no skin, and no shell you can touch or see. Only space that curves so profoundly that it turns inward on itself. You are accustomed to thinking of things as having edges, boundaries where one thing ends and another begins. But here, those lines have blurred. A black hole is not an object in the traditional sense. It has no crust, no core, no layers to peel back and explore. It is pure geometry, a region of space where the curve becomes a collapse. And yet you can feel it. The way you feel stillness before a storm or the shift in weight when an elevator begins to descend. The pull is not violent. It is ancient and gentle, like the moon's tug on the tides. And yet, it is unmistakable. It asks nothing of you but to notice. And so you do. You start to realize that this is not a thing you are observing. It is a place. A black hole is where gravity is victorious. Where no other force, not light, not pressure, not time itself, can push back. You imagine space as a fabric, like soft silk stretched over a frame. A star creates a dimple in the cloth. A black hole is where the cloth is torn, not sharply, but infinitely downward. That tear has no bottom. You peer into it, hoping to see something, anything. But there is nothing to reflect your gaze. The event horizon, the wall, the invisible boundary you've come to know, offers no texture. It is not a veil, but an absence. And yet, around this absence, reality reshapes itself. Time flows differently here. Clocks tick more slowly as you get closer. Not because they are broken, but because time itself is stretching. It's as if you are walking through thickening air, with each step taking a little longer than the last. Einstein foresaw this long before anyone could imagine testing it. To him, gravity was not a force that pulled, but a curvature of space and time. Mass tells space how to curve, and space tells mass how to move. A black hole is the deepest curve that relationship allows. But here's the strange part. The black hole isn't reaching out to pull you in. It's simply there, stable and indifferent. It is you who are falling. Not because it beckons you, but because space itself slopes toward it. You remember a childhood feeling of running down a hill and realizing you're not fully in control. Not yet falling, but no longer able to stop. That's what this feels like. Not panic, just inevitability. And yet you are calm. Because this place, for all its mystery, holds no chaos. It is quiet, ordered. Its rules are strange, but they are precise and predictable. Within the madness of its density lies a certain serenity. Even as it bends space, stretches time, and redefines the laws you thought you knew, the black hole remains silent, steady. You wonder how such power can have no face, no eyes, no flame, no roar. Just gravity with no expression. It makes you reconsider what power is. Perhaps true power doesn't need to be loud. Perhaps the most profound truths in the universe aren't hidden, they are just quiet. You ponder what might lie beneath the horizon, beyond your reach. Physicists call it the singularity, a point or a region where density becomes infinite, where our equations, so elegant in the outside world, begin to shudder and fail. Some believe the singularity is a physical reality. Others think it is a sign that our understanding is incomplete, that the truth is not infinity, but something we haven't yet learned how to describe. You let the question rest. Sometimes, not knowing is its own kind of peace. The black hole exists not to solve your questions, but to hold them gently, like a dark cradle for uncertainty. You float closer, not falling or flying, just drifting through the calm thickness. Around you light bends, stars warp into crescents. Their images stretch into arcs as they pass behind the black hole's gravity. This effect, called gravitational lensing, creates a strange, beautiful distortion. A mirror held up to the cosmos, curved, broken, and radiant. It reminds you that even in darkness, there is form. Even in absence, there is presence. You are beginning to grasp that the black hole is not empty. It is full of curvature, of energy, of ideas that do not yet have names. It is a story written in the language of gravity. And in this story, you are a silent observer. You watch as the stars behind you shimmer with distortion. You feel time breathing slowly around you. You sense a stillness that is deeper than silence. And then a tremble, not within you, but in space itself. A wave begins to move through the fabric. Not a wave of light, not a pulse of air, a wave of gravity. You cannot hear it, but you feel it. The black hole you've been drifting next to has started to move. Not by choice, not alone. Something massive has come near another black hole. And now the two are beginning to spiral. Not violently, not in haste, but in a slow, powerful dance that will soon send ripples across the universe. There is something paradoxical at the heart of this story. A core with no pulse, no surface, no shape. You've been drifting through the curved calmness of a black hole's outer region, floating near the event horizon where light bends and time thickens. But now your focus shifts inward, not just deeper into gravity's hold, but toward the very notion of a center, toward something physicists call the singularity. It's a haunting word, one that carries weight and reverence, but very little clarity. You try to imagine it. What does it mean for something to be infinitely dense? For all the matter that once formed a star, a thing larger than 1,000,000 Earths, to collapse into a point with no volume. Your mind reaches out gently, but there is nothing to grasp. The image slips away as if your thoughts are fingers trying to hold smoke. And perhaps that's fitting, because the singularity is not something to be seen. It's something that marks the place where seeing ends. In mathematics, the singularity is where your equations stop working, where numbers fall off cliffs and infinities appear like cracks in ice. The normal tools of physics, beautiful, elegant, and predictable, begin to falter here. Space is no longer stretched, it's pinched. Time is no longer slowed, it's twisted, looped, and folded into itself like a knot of unknown size. This is the limit of what we can describe. And yet, the singularity is not a physical object. It's not sitting there glowing or spinning. It's not a particle or a place you could go. It's a boundary in our understanding, a crack in the map of what is known. It's as if the universe drew a line and whispered, "Beyond this, I no longer speak your language." And somehow you find that reassuring. Because not every mystery has to be solved to be sacred. Some are meant to be held with reverence, like a quiet final note of a song. You imagine falling inward, not quickly, but gradually, toward that unknowable center. What would it feel like? Would it be heat, pressure, light, or something completely beyond human experience? Einstein's equations suggest that time itself would end at the singularity, that all directions would collapse, and that even the concepts of before and after would become meaningless. But other voices chime in. Quantum physics, the theory of the very small, does not agree with this total collapse. It whispers of uncertainty, of particles dancing with probability, of energies flickering in and out of existence. It suggests that perhaps the singularity is not a point but a veil, not an end but a beginning. You float between these two truths, allowing them to contradict, allowing them to coexist, not in a conflict, but in rhythm like waves meeting in the dark. Because at the edge of understanding, contradiction is not a failure. It is a sign that you are near something real. The singularity might be a point, a cloud, or a bridge to somewhere else. Or perhaps it is not a thing at all, but simply a limit to our way of seeing. Some theories propose that the singularity never fully forms, that quantum effects prevent the collapse from finishing, like a parachute slowing a descent at the very last moment. Others suggest that a black hole's core is not an endpoint but a wormhole, a tunnel through space and time that opens into another universe. You breathe in the wonder, not rushing to an answer. Because here, in this imagined heart of darkness, all stories become quiet. You remember the concept of entropy, the tendency for things to fall apart, to spread out, and to become less ordered. A singularity seems to defy this. It gathers everything into a single point. But perhaps that is the greatest dispersal of all, where even order and disorder lose their meaning. And now something begins to change. The black hole you have been watching is no longer alone in its stillness. The space around it has begun to stretch in subtle, rhythmic ways, like a drumhead under tension, like the breath of something vast preparing to move. Another black hole has entered the scene. You don't see it directly, you feel its presence. Its own gravity is beginning to touch the horizon of the first one. Not like a forceful push, but more like a recognition, a gentle leaning in. They begin to spiral toward each other. This is not a collision in the normal sense. There are no sparks, no cracking sounds. These are not objects slamming together. They are regions of space-time folding into each other. Their identities begin to blur, their boundaries soften, and deep within each of them lies a singularity. What happens when two of these mysterious centers meet? What does it mean to combine two infinities? Our equations struggle here. Even our simulations begin to falter. The math predicts that gravity will ripple outward. A gravitational wave will blossom from the union. But at the core, where the singularities touch, we don't yet know. Some believe a new, larger singularity is born. Others wonder if the singularities vanish entirely, replaced by something we have not yet named. We can measure the waves. We can hear the cosmic chirp of their merger. But the heart of the mystery remains hidden. And so you float in silence once more, not outside the black hole now, but within its imagined depths, past the horizon, past the photon sphere, past time itself. You hover near the place where knowledge ends and wonder begins. And as the two black holes get closer, their darkness begins to hum, not with sound or light, but with the trembling of the universe itself, preparing to speak. You are falling, but not in any way you've ever fallen before. There is no wind, no ground rushing up to meet you. Just an endless descent, like a thought circling itself, soft, quiet, and continuous. You've crossed the event horizon, the boundary that light cannot pass. There is no going back now, but there is no crash either, no sudden change. The fall is gentle, patient. It feels less like moving downward and more like drifting inward toward a place the universe keeps shrouded in mystery. In normal space, falling has an endpoint, a bottom, a landing. But here, inside the black hole, there is no such floor. Instead, space itself is collapsing inward with you. The very shape of reality narrows, folds, and thickens. Outside, time still flows. Stars still burn. People still speak, breathe, and dream. But for you, time is no longer a background. It is a direction, and that direction is inward. You begin to realize something strange. From the perspective of someone far away, still safely outside the black hole, you never fully fall in. To them, you would appear to slow down, to freeze, just above the event horizon. Your image would linger like a shadow that refuses to disappear. Light from your final moment would stretch thinner and thinner, redder and redder, until it faded into invisibility. But from your perspective, time moves on. You're still falling, still moving forward. There is no pause, no freeze. Only the feeling that everything around you, space, time, even your thoughts, is becoming something new, stretched, and strange. Slower in one sense, deeper in another. It's not frightening anymore. In fact, it feels like the quietest kind of journey, as if the universe has taken you into its hands and said, "Come see how deep I go." You try to measure the distance you've traveled, but it becomes impossible. There are no landmarks here, no stars, no way to look back and measure what was. Even the concept of direction begins to blur. You are no longer falling through space. You are falling through time itself. Imagine being inside a waterfall, but the water is made of moments, and each moment pulls you downward, inward, deeper into the current. And here is the strangest thought of all: the deeper you fall, the faster time passes outside of you. The universe, from your viewpoint, is accelerating. Galaxies spin faster. Stars are born and die, and civilizations rise and vanish, all in the blink of your slow-moving eye. The rest of time speeds up while you stretch. This is called gravitational time dilation. The stronger the gravity, the slower time passes. And nowhere is gravity stronger than in the depths of a black hole. You are now in a place where the rules bend, not in ways that break, but in ways that reveal the limits of our understanding. Everything you've known about motion, clocks, and cause and effect begins to blur. And yet you are still conscious, still aware, still falling. But here is a question: will you ever arrive? Will you reach the center, the singularity? Or will you fall forever, chasing a point that always stays ahead? Some theories suggest that the singularity is not a place you reach but a moment you become. That your fall is not toward something but into something. Not a destination, but a transformation. Others propose that in your final moments, you would be compressed, not just physically, but temporally. Your entire future, every thought you might have, would be squeezed into a sliver of time just before impact. But you don't feel crushed. You feel stretched, widened, and unfolded across seconds that refuse to end. You wonder what it means to fall in a place where down is no longer down, where time doesn't flow but pulls, where every step forward is a deepening curve in the path of existence. You begin to see falling not as a failure but as surrender. You are giving yourself to gravity, not as a victim, but as a traveler. Outside, the universe grows older, entire galaxies wink out, and new ones flare into being. You suspect that if you could look backward, the universe would appear to evolve and fast forward. The stars would seem to race, aging in seconds. But you are timeless now. Perhaps this is the closest one can come to stillness while still moving. And then you sense a deep, subtle trembling. It is not inside you, it is in space itself. A kind of deep, structural resonance, as if reality has been plucked like a string. As if the fabric of the cosmos has begun to hum. You are not the only one falling. Somewhere nearby, another black hole is descending into this same spiral, not along the same path, but toward the same idea. Two gravitational giants, circling each other invisibly, begin to draw closer. Their orbits shrink. Their horizons distort. Their identities start to merge. And in the space between them, something extraordinary is about to happen, a merger. A moment when not one, but two of these ancient, invisible hearts become one. And when they meet, the fall will no longer be silent. It will ripple. It will shake the universe. It begins without a sound, not because the event is quiet, but because silence is all space permits. There is no air here, no atmosphere to carry vibrations. But still, the universe shudders, and if you know how to listen, it sings. Two black holes have found each other not by chance, but in a slow, inevitable dance. They have been circling for eons, spiraling closer in invisible paths, shedding energy with every orbit. Not in sparks, not in light, but in something stranger, and until recently something completely undetectable. Ripples in space-time, gravitational waves. They flow outward now from the black hole pair, spreading through the cosmos like invisible rings in a dark pond. These waves are not made of matter or light. They are made of geometry, distortions in the very fabric of existence. You don't hear them, you feel them. If you had the right kind of detector, if you were standing perfectly still in a vast, quiet vacuum with instruments tuned to absurd sensitivity, you would measure the smallest stretch. A widening and narrowing of space itself, a squeeze in one direction, a lengthening in another, a movement not of things within space, but of space itself. It is a kind of cosmic heartbeat. And this particular one began over 1 billion years ago. That's how long it took the ripple to reach us, traveling at the speed of light across intergalactic distances. When it arrived, it didn't roar. It chirped, a tiny, precise blip, measured not in seconds but in fractions of a breath. And yet, in that moment, something extraordinary happened. For the first time in human history, we heard the sky tremble, not in light or radio, but in gravity. LIGO, the Laser Interferometer Gravitational Wave Observatory, captured it. A signal from deep space. Two black holes, each dozens of times more massive than our sun, spiraling into each other. Their collision didn't produce light, but it created a ripple that passed through our planet, through your body, and through every atom without resistance. The wave didn't cause any damage. It didn't even tickle. It stretched Earth by less than the width of a proton. But in that delicate tremor, it carried a message older than most galaxies. And the message said, "This happened far away, a long time ago, but it was real, and now you know." You float in thought, imagining the moment of the merger. Two black holes, their horizons brushing, then melting together. Not a burst, but a folding. Gravity deepening into gravity. Masses uniting, identities vanishing. A new black hole is born, larger, smoother, and spinning more rapidly. But not all of the original mass remains. Some of it is converted not into heat or particles, but into gravitational energy in the waves you now feel. And that's the paradox. These waves, so quiet and so soft, carried more power in that instant than all the stars in the universe combined. For a brief moment, that merger outshone the cosmos, not in light, but in gravity. You realize something else. These ripples are everywhere. Right now, as you rest, space itself is still ringing softly constantly from other mergers, other spirals, and other cosmic dances throughout time. The universe is not silent, it murmurs. Each black hole collision is a bell tolling from afar. Each merger is a note in a song we are just beginning to hear. And if we keep listening, with more instruments, more patience, and more wonder, we might begin to hear not just individual events, but a complete gravitational symphony, the soundscape of spacetime itself. You close your eyes and imagine it. The universe not as empty, but as resonant, not mute but slow to speak. You wonder what else might leave an echo: supernovas, neutron stars spiraling inward, the early hum of the infant universe, still reverberating in the background. And then you wonder if gravity can ripple, can it also tangle? Can the waves interfere, overlap, and form patterns? Could they leave imprints on the paths of galaxies? Could they encode a kind of memory in the shape of space? These are questions that don't have answers yet. But the act of asking is enough. You feel your mind gently expand like the waves themselves, stretching through curiosity. And now the two black holes have become one. The waves from their union move outward in all directions, carrying the final note of their spiral. But here, near the event horizon of this new singular mass, another ripple stirs. A smaller tremor, it's not from the merger itself, but from the fabric of space settling down. The newborn black hole wobbles slightly, not visibly, but mathematically. And those wobbles also radiate outward in waves. We call this ringdown, the final settling of a black hole into its new shape. Like a bell that is still humming after being struck, you listen to the last reverberation. You imagine how much information is lost, or perhaps not lost, but merely hidden, encoded on the edge, written in curvature, inscribed not in ink, but in time. And even now, as the universe begins to quiet down again, another signal is on its way. Another ripple, another echo, another pair of black holes somewhere out there, nearing their spiral. And when they meet, space will shiver once more. You drift now alongside something ancient in motion. Two black holes, neither visible nor glowing. Yet their presence is unmistakable. You cannot see them with your eyes, but you feel their influence in the warping of the stars behind them, the slow swirl of dust, and the bending of the background light.